So in this video, we'll be looking at questions 15 through 20 on the rational expressions test review. Okay, so in number 15 on the review, we have these three fractions that are all being added together. Now the numerators are all 1, but the denominators are different. So the first thing I'm going to do is factor the denominators. You see in this first one, it becomes x plus 4 times x plus 3 in factored form. The middle fraction, it's a difference of 2 squares, so that becomes x plus 3x minus 3. And then same with the third one, the difference of squares, that's x plus 4x minus 4. So we are going to look for the lowest common denominator, or the least common denominator of all these factors. So obviously we have x plus 4 times x plus 3. And then we have x plus 3x minus 3 and x plus 4x minus 4. Well, when you look at all of these, what you end up with is the x plus 3x minus 3. And then the x plus 4, x minus 4. And those are the common factors of all of these. So then what we're going to need to do with this first fraction here, the current denominator is x plus 4, x plus 3. So we're going to have to multiply 1 times the other factors that are not part of the current denominator, which would be the x minus 4 and the x minus 3. So that's what you see right here because I've just multiplied 1 times those. So x minus 3, x minus 4. Plus, and then 1 times x plus 4, x minus 4, because the x plus 3, x minus 3 were already part of the denominator. So that's what was left. And then in this fraction, it had the denominator had current factors of x plus 4, x minus 4, so we had to multiply the numerator times x plus 3, x minus 3, and that's what you see here, okay? Now it's a matter of actually multiplying these, so we have to FOIL these first two binomials. We get x squared minus 7x minus 12. Then we have to FOIL these second two. We get x squared minus 16, and we FOIL these last two. We get x squared minus 9, and of course it's all over this common denominator of x plus 3x minus 3 times x plus 4 times x minus 4, okay? Then we just start looking for our common, or we start combining our like terms. We have an x squared plus 1x squared plus 1x squared, which is 3x squared. We have a minus 7x, and that's the only x term, so minus 7x. And then minus 12, minus 16, minus 9 is minus 13. And then since I know this cannot be factored, and we will not be marking out any common factors with the numerator and denominator, I went ahead and multiply all these, and this is what you get. X to the fourth minus 25x squared plus 144. All right, number 16. We have subtraction and addition, okay, combined. But again, we need to start with a common denominator. Now, this first fraction is just the denominator is a factor of x minus 1. The second fraction just has a factor of x in the denominator. And this third fraction is, the denominator is x squared minus 1. Well, I'm going to factor that. That's the difference of squares, so x plus 1 times x minus 1, okay? All right. Well, now when I look at all of these, I realize that the common denominator is the x times x plus 1 times x minus 1. You can see that they have x minus 1 and x minus 1 in common, but we don't have to represent that twice, just once, okay? So what I'm going to do here then is this 3 is going to have to be multiplied times x and times x plus 1. So that's what I have here, 3 times x plus 1, which is actually 3x times x plus 1. And then minus 2 is going to have to be multiplied times the x minus 1 and the x plus 1, which ends up being negative 2 times x squared minus 1. And then finally, this x plus 3 is going to need to be multiplied only by the factor of x because it has the other two. Okay, so x times x plus 3. All right, when we multiply all of this in the numerator, we get 3x squared plus 3x for the first fraction, minus 2x squared plus 2, that's right here, minus 2x squared plus 2, because we have a minus 2 minus 1, that's plus 2. And then finally, this third fraction of x times x becomes x squared, and x times 3 plus 3x. So all of these terms, all over the greatest common, or the lowest common denominator of x times x plus 1 times x minus 1. Okay, when you combine your like terms here, you get 2x squared plus 6x plus 2, all divided by x times x plus 1 times x minus 1. Well, you will see that you're not able to factor this to a point where we're able to find any common factors in the numerator and denominator. So we can simply write our answer with the numerator that we have and then go ahead and multiply the denominator and we get x cubed minus x. All right, number 17. So in this one, we have an addition of some rational expressions and subtraction. All right, so again, I'm going to go ahead and find my common denominator. My lowest common denominator, we have an x plus 5 times x plus 10 for the factors of the first fraction in the denominator, and then 2 times x plus 10 for the second fraction, and then the third fraction, the denominator simplifies to 2 times x plus 5. So x plus 5, x plus 10, and 2 is going to be the common denominator, all right? So I have that represented here. So in this first fraction, the x, the only factor it doesn't have is the 2. So we have to multiply x times 2, or 2x. And then the 7, the numerator of the second fraction, the factor that it does not have in the denominator is the x plus 5. So we have 7 times x plus 5. And then minus 3. And the factor that is missing here is the x plus 10. So we're going to multiply the minus 3 times x plus 10 with our common denominator. Now, when we do that, this, of course, is 2x plus 7x plus 35 minus 3x minus 30. And all of that over our common denominator. Then I combine my like terms, and you get 6x plus 5 divided by 2 times x plus 5 times x plus 10. We'll not be able to simplify this anymore, so we go ahead and multiply our factors in the denominator. And this is our final answer, 6x plus 5 all over 2x squared plus 30x plus 100. So in number 18, we have an x minus 3 over 2 plus 1 over x divided by 1 over x minus 1 over x squared. Okay, so this has a combination of adding rational expressions, subtracting rational expressions, and dividing. Okay. So the first thing we have to do is deal with the numerator of the division problem. And we're going to need to find a common denominator of these two fractions that are in the numerator, 2 and x. Well, that's going to be 2x. So obviously we're going to have to multiply x minus 3 times the x, which I showed here, and then plus 1 times the 2, which is shown here. All of that over 2x. Then in our denominator, we have 1 over x minus 1 over x squared. And this is where we had maybe a little bit of trouble understanding the lowest common denominator, okay? Well, that's going to be x squared, because this has a factor of x, but this has a factor of x times x. So we're simply going to need to multiply this side by an additional x. So here I represent the 1 times just the x minus 1, and we don't have to multiply by anything because the common denominator is x squared, okay? Now, let's go ahead and do the multiplication. So x minus 3 times x is x squared minus 3x, and then plus 2, all over 2x, divided by, and then this just down here is x minus 1 over x squared, okay? Now we have this division problem where we've cleared out our fractions, or our common denominators, okay? And I'm going to divide this fraction, by this one, by simply multiplying by the reciprocal. So the first fraction, x squared minus 3x plus 2 over 2x, gets multiplied times x squared over x minus 1, okay? Then I'm going to start factoring my expressions to see if I have any that I could cancel. This x squared minus 3x plus 2 is actually x minus 2 times x minus 1 in factored form over 2x. and then again, x squared over x minus 1. Well, you can immediately see that this x minus 1 and x minus 1 have in common, so they will cancel each other out, all right? And then this 2 times x and this x squared, they have an x in common. Now, in this x squared, one of the x's will remain. Here, only the 2 will remain. So now it's just x minus 2 times x, and then 2 times x. I'm sorry, just 2 times 1. All of this got canceled, okay? So times 2. Well, there's no common factors, but we have x squared minus 2x over 2. All right, let's take a look at number 19. So it's a very similar problem, okay, where we need to add our fractions in this numerator and add our fractions in the denominator and then do the division, okay? So the common denominator of these fractions here in this numerator is 3 and x, okay? So 3 times x is 3x for our common denominator. Now, each fraction separately, the x plus 4, it has the factor of 3 in its denominator, but not the x. So we're going to have to multiply all of that, x plus 4 times the x, plus 1 times the 3. So I've represented all of that here. And then in the denominator, this 1 has a denominator of 1. So 1 times the x would be x. That's the common denominator. And then we have to multiply this fraction on the left, which 1, it's 1 over 1, but it'll be 1 times the x plus 1. This fraction doesn't change, okay? So that's going to equal x squared plus 4x plus 3 over 3x here in this first fraction, divided by, this just becomes x plus 1 over x, okay? So now we no longer have the fractions that we have to add together or anything, but we need to divide these two functions. So we're going to multiply by the reciprocal. So the first function, the first expression, x squared plus 4x plus 3 over 3x times x over x plus 1. Then we factor our expressions, okay? X squared plus 4x plus 3 becomes x plus 3 times x plus 1. And then times x, and then we have a 3x and an x plus 1 in the denominators. So they have an x plus 1 in common, a factor of x plus 1 that we can mark out. This 3x in the denominator of the fraction on the left and the x of the numerator of the fraction on the right, they share the x. So when we mark out those x's, we're left with 3. So basically we just have x plus 3 in the numerator and 3 in the denominator. And that is our solution. So in this question number 20, same thing, we have a fraction minus 1 in the numerator and then another fraction plus another fraction in the denominator. Okay, so it's a combination of addition and subtraction and division. First things first here, these fractions that are in the numerator of the original problem has a common denominator of 9. So I have to multiply, or I don't have to multiply x squared times anything because the common denominator is 9, but minus 1 times 9, all over 9. In the denominator here, we have 9 times x. So the common denominator of these fractions is 9x. That means I have to multiply x minus 6 times the x plus 1 times the 9. All right. We work all that out. We get x squared minus 9 over 9. Divided by x squared minus 6x plus 9 over 9x, okay? Then I'm going to write that problem as a multiplication problem. So the first fraction doesn't change, x squared minus 9 over 9 times, and then the reciprocal of this one is 9x over x squared minus 6x plus 9. Here I'm going to factor these expressions. This x squared minus 9, that's the difference of two squares, x plus 3 times x minus 3. Over 9, and then times, that's going to be 9x over, and this trinomial becomes x minus 3 times x minus 3, or x minus 3 squared. So you can see we can cancel out one of the x minus 3 factors. The 9x and the 9 have a common factor of 9, so we're just left with x up here. So x plus 3 times x, which is x squared, and that should say plus 3x. and then all over just x minus 3 here, okay? So that will be your final answer there. All right.